The National Electrical Code, or NEC, addresses the bonding requirements for aluminum cable trays used as equipment grounding conductors, often referred to as EGC. If an aluminum cable tray is listed for use as an EGC, a separate bonding jumper around the bolted splice connectors is not strictly required provided certain conditions are met. These conditions are: firstly, the cable tray system must be continuous and securely bolted together. Secondly, the splice connectors must be of the bolted type and installed according to the manufacturer's instructions. Thirdly, the bolted connections must be torqued to the manufacturer's specified torque value. Now, even if these conditions are met and the NEC doesn't mandate a separate bonding jumper, it's generally considered a good practice to install one around bolted splice connectors in aluminum cable trays. This is for several reasons, including, firstly, it provides an additional path for fault current, reducing the risk of arcing or overheating at the connections. Secondly, it ensures a reliable electrical connection, especially in environments where vibration or movement may occur. Thirdly, local codes or specific installation standards might require it. The common practice, or norm, can vary depending on the industry and the specific application. In many industrial and commercial settings, installing bonding jumpers around bolted splice connectors in aluminum cable trays is quite common. However, in some residential or lighter-duty applications, a bonding jumper might not be deemed necessary. To summarize, while the NEC doesn't strictly require a separate bonding jumper under the specified conditions for aluminum cable trays listed as EGC, adding one is a recommended practice. This provides an extra layer of electrical safety and improves the overall reliability of the installation. The final decision on whether to include a bonding jumper should consider factors like the importance of the installation, relevant industry standards, and any applicable local codes. When dealing with electrical systems and grounding, it is always best to err on the side of caution and ensure all connections are as robust and reliable as possible. A well-bonded cable tray system enhances safety and minimizes the potential for electrical faults. This approach can lead to a more secure and dependable electrical infrastructure. It is important to delve into the specifics of why bonding jumpers are recommended even when not explicitly required. Firstly, the additional fault current path provided by a bonding jumper is crucial. In the event of a fault, the electricity needs a clear and low-resistance path back to the source. Without a reliable path, the fault current can take unintended routes, leading to arcing, overheating, and potentially causing fires or equipment damage. A bonding jumper ensures that the fault current has a direct and safe route, minimizing these risks. Secondly, the assurance of a reliable electrical connection is particularly vital in environments prone to vibration or movement. Over time, bolted connections can loosen due to these factors, increasing resistance and reducing the effectiveness of the grounding system. A bonding jumper acts as a safeguard, maintaining a consistent and reliable connection even if the bolted connection degrades slightly. This is crucial for maintaining the integrity of the grounding system over the long term. Thirdly, the compliance with local codes and installation standards is a non-negotiable aspect. Many jurisdictions have specific requirements that go beyond the general guidelines of the NEC. These local codes often reflect the unique conditions and needs of the area, and they might mandate the use of bonding jumpers in specific situations. Always consult with local electrical inspectors or authorities to ensure full compliance with all applicable regulations. To provide a clear understanding, consider a typical industrial setting where heavy machinery and equipment are in constant operation. The vibrations and mechanical stresses in such environments can gradually weaken bolted connections in cable tray systems. By installing bonding jumpers, you create a redundant grounding path that compensates for any potential loosening or corrosion of the bolted connections. This ensures that the equipment remains safely grounded, reducing the risk of electrical hazards and downtime. In contrast, a residential setting might have less stringent requirements due to the lower levels of electrical demand and mechanical stress. However, even in residential applications, it's prudent to consider the long-term benefits of installing bonding jumpers. Factors such as the age of the building, the quality of the electrical installation, and the presence of sensitive electronic equipment can all influence the decision. In situations where sensitive electronics are used, a more robust grounding system can help protect against voltage spikes and electrical noise, ensuring stable and reliable operation. When it comes to making the final decision about bonding jumpers, it is essential to evaluate the criticality of the installation. For example, in a hospital or data center where uninterrupted power is vital, the cost of downtime due to an electrical fault can be extremely high. In such cases, the added expense of installing bonding jumpers is a small price to pay for the increased reliability and safety they provide. In less critical applications, a more cost-conscious approach might be acceptable, but it's still important to carefully weigh the potential risks and benefits. Industry standards also play a significant role in determining the appropriate bonding practices. Organizations like the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, publish guidelines and standards that provide detailed recommendations for grounding and bonding in various types of electrical systems. These standards are developed by experts in the field and represent the consensus of best practices. Following these standards can help ensure that the electrical installation meets the highest levels of safety and performance. Finally, it is crucial to consider the specific characteristics of the aluminum cable tray system itself. The manufacturer's specifications and instructions should always be followed carefully. These instructions will provide valuable information about the proper installation techniques, torque values for bolted connections, and any specific bonding requirements. Ignoring these instructions can compromise the integrity of the grounding system and potentially void any warranties. To further elaborate on the technical aspects, let's consider the role of impedance in grounding systems. Impedance is the total opposition to current flow in an alternating current, or AC, circuit, and it includes both resistance and reactance. A low impedance grounding path is essential for quickly clearing fault currents and minimizing voltage rise during a fault. Bonding jumpers help reduce the overall impedance of the grounding system by providing a direct and low resistance path between cable tray sections. This is particularly important in systems with long cable runs, where the impedance of the cable tray itself can become significant. In addition to impedance, it's also important to consider the phenomenon of galvanic corrosion. When dissimilar metals are in contact in the presence of an electrolyte, such as moisture, a galvanic cell can form, leading to corrosion of one of the metals. Aluminum is particularly susceptible to galvanic corrosion when in contact with steel or other dissimilar metals. Bonding jumpers can help mitigate this risk by providing a more uniform electrical potential across the cable tray system, reducing the driving force for galvanic corrosion. To ensure the effectiveness of bonding jumpers, it is crucial to use appropriate materials and installation techniques. Bonding jumpers should be made of a conductive material that is compatible with the aluminum cable tray, such as copper or aluminum. The jumpers should be sized appropriately to handle the expected fault current, and they should be securely connected to the cable tray using listed connectors and hardware. The connections should be clean and free of corrosion to ensure a low resistance connection. Regular inspection and maintenance of the cable tray system are also essential for maintaining the integrity of the grounding system. Inspection should include checking for loose connections, corrosion, and any signs of damage to the cable tray or bonding jumpers. Any issues should be addressed promptly to prevent the grounding system from degrading over time. In conclusion, while the NEC provides specific guidelines for bonding aluminum cable trays used as EGC, it's important to take a holistic approach to grounding and bonding. Consider the specific application, industry standards, local codes, and the characteristics of the cable tray system itself. By implementing best practices and paying attention to detail, you can ensure a safe and reliable electrical installation that protects people and equipment from electrical hazards. The practice of installing bonding jumpers on aluminum cable trays, even when not strictly mandated by the NEC, serves as a prudent measure to enhance electrical safety and reliability. This is especially critical in settings where the potential for mechanical stress, vibration, or corrosion exists, as these factors can compromise the integrity of bolted connections over time. The inclusion of bonding jumpers provides an additional pathway for fault currents, minimizing the risk of arcing, overheating, and subsequent damage to equipment or personnel. Furthermore, adhering to industry best practices and local codes often necessitates the implementation of bonding jumpers to ensure compliance and maintain a high standard of safety. The decision to install bonding jumpers should be based on a comprehensive assessment of the installation's criticality, environmental conditions, and regulatory requirements. In scenarios where uninterrupted power is paramount, such as healthcare facilities or data centers, the added protection offered by bonding jumpers is invaluable. Similarly, in environments with high levels of vibration or corrosive elements, bonding jumpers can significantly extend the lifespan and reliability of the cable tray system. While the NEC provides a baseline for electrical safety, it is essential to consider the unique factors of each installation and implement bonding practices that exceed minimum requirements. This proactive approach can prevent potential hazards and ensure the long-term performance of the electrical system. Ultimately, the investment in bonding jumpers is a small price to pay for the peace of mind and enhanced safety they provide. To add, the NEC is a comprehensive document, but understanding the specific articles related to grounding and bonding is crucial for ensuring a safe and compliant electrical installation. Article 250 of the NEC is dedicated to grounding and bonding and provides detailed requirements for various types of electrical systems and equipment. Within Article 250, specific sections address the grounding and bonding of cable trays, including aluminum cable trays used as equipment grounding conductors. These sections outline the conditions under which bonding jumpers are required and provide guidance on the proper sizing and installation of bonding conductors. Familiarizing oneself with these specific sections of the NEC is essential for making informed decisions about bonding practices. Furthermore, it is important to stay up to date with the latest editions of the NEC, as the requirements can change over time. The NEC is typically revised every 3 years to reflect advancements in technology and address emerging safety concerns. Consulting with qualified electrical engineers or inspectors can also provide valuable insights into the proper application of the NEC requirements. They can assess the specific conditions of the installation and provide recommendations tailored to the unique needs of the project. In addition to the NEC, other industry standards and guidelines can provide valuable information about grounding and bonding practices. Standards developed by organizations such as the IEE and the NFPA offer detailed recommendations for various types of electrical systems and equipment. These standards are developed by experts in the field and represent the consensus of best practices. Following these standards can help ensure that the electrical installation meets the highest levels of safety and performance. For example, IEE Standard 142, also known as the Green Book, provides detailed guidance on grounding industrial and commercial power systems. This standard covers a wide range of topics, including the grounding of cable trays, and provides recommendations for minimizing ground loops and ensuring effective fault current protection. Similarly, an FPA 70E, Standard for Electrical Safety in the Workplace, provides guidance on safe work practices for electrical personnel. This standard covers topics such as arc flash protection and lockout/tagout procedures and emphasizes the importance of proper grounding and bonding for worker safety. By consulting these industry standards and guidelines, electrical professionals can enhance their knowledge and skills and ensure that their work meets the highest levels of safety and quality. Let's delve deeper into the practical aspects of selecting and installing bonding jumpers. When choosing bonding jumpers, it is important to consider the following factors. Firstly, the material of the jumper. Secondly, the size of the jumper, and thirdly, the type of connectors. Bonding jumpers should be made of a conductive material that is compatible with the aluminum cable tray. Copper and aluminum are commonly used materials, but it is important to ensure that the materials are compatible to prevent galvanic corrosion. The size of the bonding jumper should be adequate to handle the expected fault current. The NEC provides tables and formulas for determining the appropriate size of bonding conductors based on the size of the overcurrent protection device. It is important to consult these tables and formulas to ensure that the bonding jumper is sized correctly. The type of connectors used to attach the bonding jumper to the cable tray should be listed for the application. The connectors should be designed to provide a secure and low-resistance connection. Common types of connectors include bolted connectors, compression connectors, and exothermic welding connections. When installing bonding jumpers, it is important to follow the manufacturer's instructions carefully. The instructions will provide guidance on the proper installation techniques, torque values for bolted connections, and any specific bonding requirements. It is also important to ensure that the connections are clean and free of corrosion. The surfaces of the cable tray and the bonding jumper should be cleaned with a wire brush or other abrasive material before making the connection. A corrosion inhibitor can also be applied to the surfaces to help prevent corrosion. After the bonding jumper is installed, it is important to inspect the connection to ensure that it is secure and that there are no signs of damage. The connection should be tested with an ohmmeter to verify that it has a low resistance. Regular inspections and maintenance of the bonding jumpers are also essential for maintaining the integrity of the grounding system. Inspections should include checking for loose connections, corrosion, and any signs of damage to the bonding jumpers. Any issue should be addressed promptly to prevent the grounding system from degrading over time. By following these practical guidelines, electrical professionals can ensure that bonding jumpers are properly selected, installed, and maintained, providing a safe and reliable grounding system for aluminum cable trays.